Thanks, ma'am. Thanks all. Yeah, one more thing before I start, ma'am. Is it possible that we may unmute everyone so that we can have a kind of interaction? If there is a noise in between, then again we'll go on mute everyone. Is that possible? Oh, okay. Uh, Ma'am, you are on mute if you are speaking. Okay, in chats, can others tell me if you are able to unmute yourself or anything? We'll try to start our session like making it a bit interactive, and if there is a bit of noise or disturbance, then we'll go on the same mode again. Vinita ma'am, you there? Uh, yeah, ma'am, can we make like can we unmute everyone just to make it a bit interactive? Yeah, yeah. Okay. Uh, I see few people are unmuting themselves, and if there is a noise, then we can go on mute. Okay. And because I don't want to keep talking to myself only, so uh, okay. And one more request, and if that is possible, only then. If it is possible, you can turn on your cams as well, so I can see whom I'm talking to. Okay, that's only if it is possible. If not, that is fine, absolutely fine. Okay, so with that mention, let's get started. You all, and 1 second, let me see the poll results. I think that is done. Okay, so I see very less votes, only 7 votes. Others, you are able to see the poll? Okay, you can do that meanwhile, and I will try to share the resources by the end of this session so that if whatever is relevant, you can make use of it. So, with that mentioned, let me share my screen. Hope you all are able to see. Just a message in the chat would be sufficient for me. As it visual. Okay, perfect. Thanks, Aditya. You're the only one person who replied. Okay, perfect. So, what we are going to study today is we'll try to see how when you open a Netflix, right? How do you see a row where you can see series, documentaries, movies, videos, different types of content, right? So we are going to learn generics, and then we are going to see how in Netflix they make use of generics and provide us that screen. Okay, and then we are going to spend some time on learning the list, which is a part of collections. And then we are going to understand that in the Spotify, I hope everyone is aware of Spotify. I'm just taking as an example. So in Spotify, how does the playlist work? How list is used? What are different operations available in the collections from the list domain? And we will see how those operations we can make use in creating the Spotify playlist. And finally, this map is like a dictionary. We will try to understand everything in the map, and then we'll see how we can make use of map and implement an Uber application. Okay, so hope it is clear. We are going to spend our time on three topics, and we are going to implement Netflix, we are going to implement Spotify, we are going to implement um, what was the third one? The Uber app. Okay, not the actual app, but we'll try to see how these concepts are used. So with that mention, let's move on. So, what is actually a collection? Okay. Now, before I start this, maybe okay, it would be different answer for everyone. I just wanted to ask how familiar are you with collections framework? But we will not use any jargons today. Okay, we will not use any complex keyword because end of the day definition you can find it anywhere. We'll try to understand it in such a way that the image gets saved in your brain. Okay. So when we say collections, right, not only Java, be it Python, JavaScript, or any language, any tech stack, okay, whether you are MERN stack, whether you are LAMP stack, whether you are using agentic AI, whether using data science, collections is nothing but when you are operating with a group of objects. Okay, so today we will try to take Java as an example and we'll implement those programs. But what is collections is? It's basically provides us with a set of interfaces, something which gives us what to be done, but it doesn't tell us how it is to be done. So how it is to be done is the implementations of the interface. For example, collections in Java or any language, we are getting these many things. For example, list, which allows us to store multiple kinds of objects, multiple data types of objects, and there could be a fixed size, there could be a dynamic size, and there could be order based, index based, multiple types of list. Okay, and if you see, the blue color is the interface, the green color are its implementation. We are going to understand about it uh, theoretically and practically. Most of it would be practical only, and then we are going to learn about a map. So these two things overall, in summary, collections is nothing but all the interfaces or APIs or methods or classes that is available to you by the language to operate or work with the group of objects, okay, or group of items. Well, let's keep it simple. Okay, so we'll start with generics. Okay, so let's say if I ask you to write a program or a method which handles the sum for me. Okay, so what you will do, you will write a method which will take, let's say, two integers or three integers or 10 integers, and it will sum it for me. What if I pass a double? You will write one more method. What if I pass a string? The logic will change. What if I pass a big decimal? You will write one more method. So overall, if we see, what you are doing is, to implement one logic, you are writing four or five different methods. The whole purpose is because the data types are different. Okay, now that is not possible in real world. So you need to write it in such a generic way that it is reusable. Okay, and it is reusable at different places with the different data types, and it should handle all the edge cases and so on. Okay, so that is generic. Okay, so before generics, right, we had a Java collections where in list, like you will see, we will tell that you can use string data type. Okay, or you can use integer data type. So we'll limit the logic with a specific data type. But with the generics, we will be able to write a method which should intake or handle all kinds of data types, okay, wherever possible. Okay, so yeah, that's what generics is, writing your code in such a way that it is generic. Okay, now how do we write code which is generic? So instead of keeping explicitly integer or keeping explicitly string or explicitly defining your data type, you will simply say, I would put a placeholder or I would put a template, and whenever you want to use, you tell me what data type you want. Okay, that's how we'll go ahead. I think it's not clear because it's just a definition. So we'll go into the practicals. Okay. So if you see, without generics, let's say I'm adding, I've created a list, and then in the list, I'm adding a string. Okay. Now, when I try to access it, I will try to convert it into integer, which will give me class cast exception saying, hey, you stored string. But now you're trying to access integers, not possible, right? So that's where we go to generics, where we can write any kind of data type. So where are we writing? So if you see here, let me highlight it. Yep. If you see here, no, okay. Yeah. So with generics, we are providing the option to provide data types, but without generics, it's stiff, very stiff. Okay. So in generics, we have multiple types. So we'll start with generic class, where your complete class is generic. Basically, you have 100 methods. So you don't want to define generic at each method. That's where you will say, hey, you take you give me a data type at the class level, and then I can make use of all that in all my methods. Okay, similarly, we can make use of two data types, three data types with the different placeholder. So for example, I need one integer and one string, so I will give my end user the two options. You can give me t and u. So when I'm creating an object of it, you can see I'm creating this test class with the new string saying first data type is string, second data type is integer. Okay. Similarly, we'll spend one more minute of theoretical, and then we'll move to practical. No worries. So similarly, if you can see, my complete class is fine, but I need my generic only at one method. So that time I won't provide any generic template at the class level, but at the method level. Okay. I won't spend much time on the uh, the theory. Okay, let's see this one. So the font is visible. You want me to zoom in? The white color background is fine. Just let me know in the chat, is that yes or no. The font, the background, is it visible? Okay, thanks, Aditya. Okay, so what we will see is previously we were creating an array list. Okay, thanks, Rakeshwar. And then yeah. So previously what we were doing is we'll go ahead with empty array list. Okay, we are not saying what data type it is. Means it will allow us to store any data type. It will allow us to fetch any data type. Okay, but we want to use that content, right? So we'll convert it and we'll make use of it. For example, you want to do a summation of everything that is inside the list. So what happens here? You stored something, you fetched something. Now if you want to run it generic and then before, okay, you can see that there is a warning and there is a class cast exception saying, hey, you are saving uh, a string data type, but you are getting integer. Now here you can say, hey, you are doing it explicitly, that's why you're getting the error. Yeah, but if without generics in real time, this is what will happen. Here you will fix it because that is 3 lines of code, but in real time it's not feasible. So if I write the same thing with generics, what I'll do is I will, before I start writing my program itself, I will restrict it. Okay, hey, here you go with integer, but where is generic here? So when list is defined, the actual class, the code in the Java, okay, the code base, because this is a library, right? This is a list provided by the Java people, right? So I am already telling them, hey, I'm going to make use of your class and I'm going to make use of integer. It means what they would have written in their code, they would have provided me the class saying it's a T. So now if I make use of this their generic class by providing the data type explicitly, and then if we see, then it would work fine. I got no error, right? So I need not to convert it like how they did before. The conversion is not needed, and then I need not to be afraid of handling these kind of exception. So this is where the the generics is important. Now this is a very base example. We will go with a few more example and then you can see. Okay, so uh, don't worry, take 5 more minutes and we'll try to understand more in depth. Okay, now for example we are moving to one more topic, bounded type parameters under generic only. So when you're defining a method, right, the summation of string is different compared to the summation of integer, double, big decimal, right? You agree? Because there the append will happen, here the actual sum will happen. So the logic that you are writing, you want to restrict, you want to make it generic, but you want to restrict. So what you will say is, I am going to write a class for sum, and let me see, and any data type you can use, but it should extends a number. I hope you know what is extends or what is super. So if you have an interface, do you know extends or super? Just mention in the comments, I mean in the chat. Okay, perfect. So extends, you know, right? The inheritance concept. So extends is downwards. So number is a parent, and the child of it is integer, decimal, big decimal, float, all those things. Okay. So here I'm restricting by defining a saying that I will do the summation. Okay. I will do the summation, but the data type that you should send me should be belonging to this data type. What is data type? Any data type which extends a number. So means you can pass integer, you can pass double, you can pass float, but you cannot pass string. I hope you understood. So first we made it generic in the previous slide. In this slide we are making it generic with some constraint saying you can pass any data type, but it should extends a number. Okay. So if we try to implement the same thing in example, let's see. Yeah, this one. So here if you see, I said add. Okay, let me um, make it a bit bigger. Okay, I hope. If not, let me know. I'll increase the font a bit more. Okay, so here I said that I'm defining this method and I will return the sum for you. So here I am going to pass add, that is I'm going to call this method. I'll pass both integers, it will work for me. I'll pass both doubles, it is working for me. Okay, similarly max also. I am writing one more method, but there is one more concept here. I'll tell you in a minute. Let's try to run this. So you can see in the console that is at the bottom, we got the summation as 30 for the first one, summation of this one. Give me 1 minute. Hey, sorry. Yeah. So what we did here is we wrote logic only once, but we were able to handle data types multiple. How? By saying t. So as soon as you pass 10 and 20, it understood that your t is nothing but an integer. So what happened here? During compile time, it says t, but during runtime, that is when the program is under execution, the Java said, hey, it is not t anymore. It is integer. For whom? For this. It is double for whom? For this. Okay. Now, I hope you are able to understand. If not, just mention any question you have in the message or raise your hand. There's one more thing called comparator. You cannot compare every data types. Okay. So here I am restricting one more thing. I'm saying that you can pass any data type which is extended by number, and you can pass any data type which is comparable. So as per Venn diagram, I'm restricting all the data types which is numbers and comparable. Hope you're getting. So what is happening with comparable? I'm able to use max as well. I don't know if you are aware of compare or not, but my whole purpose was to make you understand the generic of this. So I think you are fine. Let's go to the next one. Just raise your hand on or ask me in the message if anything you're not able to understand. Okay. Yeah. So just now we discussed about the super and the extent, right? So if I let's focus on this. This is very important. Okay, whatever language, wherever you are working, this concept you will definitely use. So try. I need your 100% focus on this concept. Okay, so I zoomed in a bit for you. If you see here in this diagram, we are talking about extents. Okay, and the topic is called producer extent consumer super. What is it? Let's try to understand. So there are various kinds of templates, where are various kind of this kind of question marks. There is various kinds of flow, there is various kinds of restrictions on the data type. So what is happening here is, um, when you say extends, the flow is basically from top to bottom in the inheritance. So if you say number, it will handle integer and double. But similarly, when you are talking about super, in super you write most concrete one, and the direction is upwards. So in the extents, the direction was downwards, right? You can see, right, it is downwards. But in the super, the direction is upward. So for example, let me go here. Yeah. uh, so for example, you have a producer and you have a consumer. Okay, now think of it in this way conceptually with a blank mind, and then we'll jump onto the programming. Okay, if you have an item in your hand, if you have a fruit in your hand, you exactly know what kind of fruit it is. Correct, you agree? So when you are producing, right, you need to be very specific. You are producing an integer, or you are producing, what are you producing? Okay, so that's why when you are producing, you will be very specific that I am producing integer. Okay, so that's why inheritance is direction. But when you are consuming, okay, when you are consuming, you don't know what kind of fruit are you going to consume. So what you will say, you will say I'm going to consume a fruit. Okay, so you in your generic you will say fruit, because you don't know what kind of fruit are you going to consume, because you cannot say it is a banana, it is an apple, or what you are going to consume. So you will simply say I'm going to consume a fruit. Okay, so but when you are producing, you need to be very specific because the item is with you. Okay, so that's when you say you are producing apple, means integer, not a number. Okay, so how does this matters to you? That's a very good question, but let's see. Yep, let's see this. So when you are producing, you will use this one. The meaning is some subtype of T is allowed. Okay, the question is where you will use it. When you are writing any generics, you will make use of this acronym. everywhere you should follow the standard. Without this your program will work, but when you raise your request for others to review or when you're sending it to production, they won't allow. It's not good. So you need to understand this acronym very well. Okay, so when you are producing something you should follow this template, because you are being very specific of what you are producing. But while you're consuming, you can be very generic, like I'm going to consume a fruit, because while I am consuming data from Netflix, if I'm getting a documentation but I'm converting it into a video, that will give you a class cast exception. Okay, so um, yeah, I think if I show you program, you will understand a bit more. So let me go here. Consumer. Okay, so first we'll go with producer example. Okay, that is, we'll go with the common one. Yeah, PS. Okay, so what we are doing here is we are having two list. One is a destination, one is a source. Okay, and source is nothing but your producer, and you know exactly what items you are going to produce. That's why you will make use of so your source is producer, and if you see in the definition you wrote extends. Okay, you are being very specific of what you are allowing to produce, and here you are allowing to produce integer, right? Similarly, destination, you don't know what you are going to get or what you are going to consume. Okay, what we are trying to do here is we are writing a method called copy, where we are going to consume data from source and we are going to dump it in the destination, right? So from source what you are going to get you don't know. That's why your destination should be a generic one. So here you can see it's a number. Okay, I hope you are able to correlate. I will share this program and this presentation in the GitHub, and I'll share it in the link. So even after the session you refer it once and see, you try to execute this one. I have kept the notes, the documentation, the expected output, everything in the program and the deck. So you try to run it after this um, session. So because it's you all are muted, I'm not able to clearly understand whether you are able to get it or not. But assuming that you are understanding, I'm proceeding. Okay, so let me know if you are not able to understand. If it was interactive it would be more good, but that's fine. Okay, so I hope you understand when you are producing you need to make use of extents, where not while using it, but when you are writing a library or when you are defining a functions for other to use. Okay, so that's when you write extents and you be very specific of what you're producing. And while consuming, you can see I'm consuming items from my source and I'm dumping those items in my destination. Okay, and here even if you pass double or float anything, it will work because while consuming I'm making use of super. Okay, maybe let me run it once. Generic. Okay, so this is working. I hope you are able to understand. If not, I will have this programs deck on the GitHub. You can take a look once again. All right. So yeah, this is, yeah. What is the benefits of, okay? So we'll start with limitations. So if you see in the generics that we have done so far, nowhere you can use. Where is my, once again? Yeah, yeah. You cannot use uh, the data types. Basically you can use only wrapper classes. Okay, so if you want to make use of int you can't, but if you want to make use of integer you can. But when you are making use of these data types list, then what is inside doesn't matter, because your actual thing that you are using with generics is list. So only wrapper classes you can use is the limitation, and you cannot create an array like this anymore. You can make use of list, array list, any kind of list, and then uh, can't use class type parameter. Okay, so let's say static, you know, right? What is static? It's not it has nothing to do with the class level information. So if you are using any data on the class level, you cannot expect this to get mapped to your static variables or static instance, because this you can use without even the class creation, so it will be separate. Okay, and wildcards that we have seen just now, PECS, producer, extend, consumer, super, that is keeping restrictions on us, right? So that's one of the limitation, that it is keeping restriction, but it is for our good only. Okay. And then when you write an exception classes, okay, I don't know if you have ever written exception classes, but if you ever have a session deep dive, we will try to write exception classes. You cannot write generic exception classes, you need to be very specific. Like for example, your exception name is bad, you cannot use generics there. Okay, you need to be very specific. What is the benefits? Last 1 minute and then we move to the next topic. For sure, we can make use of code reusability, and then you don't have to typecast everything. Okay. And finally, even if you have to typecast, you don't have to typecast individually. Okay. And I think you are clear. If not, I know it's a big topic, it's a vast topic, so it will take some time. So let's quickly jump to our Netflix example, and we will spend a minute on it and we'll jump on to the new topic. So if you see, I will minimize everything. Okay. So without generics, I will ignore. With generics, let's focus. Okay. So you have a class called movie and you have a class called series. Okay. And finally, the feeder service, which is there in the Netflix, it will have a list of movies, list of series, and a combinations of it, right? Now, when it needs to show it on your screen, whether mobile or laptop, anything, when it needs to show on your screen, we will simply ask in our main function that, hey, first let's load the movies in your continue section, load series in your trending section. So here if you see, you are making use of the same function, but you are passing it different data types because you don't want to write your code again and again. So that's why with the same function you are able to load the movies, you are able to load the series also. Okay, I won't deep dive into each line as of now because of the time, but let's see how it works. Okay. So okay, so you can see this is raw where you got a class cast exception because you had a movie and try to accept the series, but in the next two you are able to get both of them. Okay. um, so I think that is making a bit clearer for you. I don't expect you to understand everything in so quickly, but try to make use of these programs practically. And for you, uh, two things that you can do is, when you search in Google, you get images, you get even videos, you get links, you get docs, you get PDFs, everything, right? So you try to make use of generic and try to implement this one search many kind of result. And in Tesla you get sensors which has data of different types. So you get noise, you get audio, you get the heat wave, different types of data. So again, try to make use of generic and see if you can implement anything. Okay, that's how you don't memorize the concept, you implement it. Okay. So if you are good, let's spend maximum 1 minute on taking some questions. So what do you think generics provide type? So option is safety, casting, reflection, serialization. So what could be the possible correct answers you think? If you are listening, you can just keep it in the message. So what type does generic provides us? Let me zoom in. Is it visible? Okay. So all of you just say hi once. I don't know whether you guys are there or you are not there. Just say hi, everyone. Okay. 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 Perfect. Perfect. So I'm getting few responses. I and can you tell me, like, so far, how clear are you with generics? I know this is a very half an hour you spent, and I cannot expect 100% that you learned it, but you can spend some time. The way I kept it with the real time example, you can spend time on it. I'll share the GitHub link. Um, so it's not casting; it's type safety. Okay. So with the typecasting, you means you need to convert from one data type to other data type, right? But the whole purpose of generics is that it doesn't. You are allowing it to write a methods in such a way that you don't have to typecast anymore. Okay, so that type safety generics will provide. And I don't think we have enough time to go through all the questions, but try to question yourself with this deck, and on the next slide you'll find the answers as well. Okay. So let's go ahead with the list. Are you all okay, or you need a 2 minutes break before we jump? Just let me know in the message. Okay, so then we will continue. Okay, so what is list? Okay, ignore program. Okay, in general, what is list? Your mom gave you a grocery list. Okay, uh, it means some list of items, right? So you need to follow it. You need to follow it in the order, or you have a duplicate, or you are following order on your own. For example, shop 1 will get me this list of items, shop 2 will get me this. So you can follow any order, you can follow duplicate elements. You have multiple such ways of manipulating that list that your mom gave to buy groceries, right? So that's a list, nothing complex. It's a simple list that your mom writes on the sticky note and give it to you, that get me those items. So it's basically an ordered collection that allows you to duplicate or search based on index, keys, or values. Not keys and values, my bad. Based on index, or based on value, or based on the order. Okay. So Spotify playlist is what we are going to implement, and we have different types of operations in list. So to start with, we can see that we have a empty list. What operations you can do? Think blank mind. You can add. Okay, you can add a duplicate, you can remove, you can try to get by using a get operation. So you have such multiple operations. Okay, that's as simple as it. It's a simple list. Okay, now if you see in list, you have array list. Okay, you have linked list, you have vector, you have stack. So you have different kinds of list based on the purpose that you want to make use of the list. For example, okay, maybe we'll try to understand that in a minute. We'll go here. So this is a playlist, and in the playlist, what you do? Okay, you add song, you swap songs, you remove some song explicitly, you sort by some filter. We will sort it by rating, and then we'll say up next. So show me the next two songs, show me the next three songs. So this is the template that we have written, and we'll try to learn it in next few minutes, and then we'll try to implement it. Okay. So hope you are good with the start, and let's try to understand the operations that we can do in the list. Okay, so if you see, we have, okay, let me go back here. In the screen, you see list is an interface. Okay, and its implementations, we have this different. This I got from Java Tpoint, this screenshot. So they gave a good diagram, so I took it from there. Okay, so these are different implementations of our list interface. We'll try to understand when to use, what to use, and why to use. Okay, so when you go for array list, what is an array in general? You know, right? In your disk or in your RAM, you have memory. So if I need 10 items to save in my array, what does array do? It keeps all the items together. Okay. Why? Yeah, let me keep it here. Okay, so if you have an array, it will keep all 10 items together. Okay, this is your complete RAM. But in you have when you're having array, why you go for array? Because you want to access this item, this item, this item. It is very frequent, because in general, if you have one item here, one item here, one item here, one item here, it is, so when you're getting it, when you're seeing the video. Okay, so let's say first ball of IPL is here, second ball of IPL is here. So to telecast it, it will be very difficult, right? But when it is in a contiguous array, I'm not taking a good example for your information, but I'm taking an example which you can understand. That's not a correct example, but I'm trying to, map the correlation. So in array, you have all the items stored adjacent. So it is very fast in fetching it because you know where it is, right? Okay. So array list is basically uh, the array that we talked just now in the list format. Okay, so when you have lots of reads, okay, when you want frequent search, when you have frequent reads, you go for array list. Okay, and this is a time complexity. I won't go deep much as of now. When you want to go to linked list, you know, right? Linked list, it's basically where you have items stored anywhere. Okay, for example, this we saw, one ball is here, second ball is here, third ball is here. So these all will be linked together with some arrow, some pointers, right? So here, what is the benefit? That it is stored anywhere. It can be as dynamic as possible. So here, the writes will be good, the orders will be maintained, but the read will be costly because You need to store extra arrows, you need to see where my next word is, you need to search, you need to traverse, and then it will get for you. So when you go for linked list, when you're mostly dealing with heads, tails, inserts, or removes, okay, we will see the example. Don't worry if you're not able to understand, we'll see the example. And then we have one copy on write array list. So if you want to keep let's say your use case needs a very secure critical pi data, like personal information data, like for example Aadhaar card, okay, you want to keep it very secure, then you can go for this kind of where it the original okay, the best example would be blockchain. Okay, so in blockchain, what happens is there is a list of items already. When you do one more transaction, when you do one more transaction, you won't, modify the existing list. You will take a copy of it, you'll append one more item, and then you'll create one more chain. Okay, so that is the best example of copy and array list. So if you want to write anything, you will copy it and then you write one more. Okay, now synchronize. Let's take synchronize one more example. I hope you know what is um, uh, deadlocks and asynchronous synchronous thing. If not, okay, maybe that is some more time. Basically synchronous list is, I have an item and you all, how many members you are? 40 members you are. All 40 members want to update it. Okay, now if you all 40 members update it, let's say I take Shivani's update. Okay, it means I'm losing all of yours because you don't have the latest copy. Okay, so I have a value called 1. Okay, Shivani wants to make it 10. Okay, so because he came first, he have access to this, but others are also having access to it. So everyone will update with different values, but it will reflect, let's say 1 plus 10 she wants to do, other wants to do different operations. But it is not possible that I will summation all because all requests came at once. So with synchronous, what I will do is I will take your request, keep it in my, or I will hold on to your request. Whoever comes first, I will give them. They will update it. Then it will become 11, then I will take a different request, then I'll make it summation. So like that, I'm handling all of your request. So synchronous means the operations that you do, I will keep it synchronized. Okay, there's more inside it, but okay, let's keep it simple. Okay, so we have different kinds of list for different purpose. That's the whole point. Okay, and let's see, we will, yeah, so these are few of the operations we can add. So add will append. Okay, we can set means it will replace. You can remove based on a value, you can remove based on the index. Okay, and then you can check whether your list contains this item or not, and if it contains, what is the index of it. If it is not there, you will get -1. Okay, and then you have a, let's say, song of, you have 10 songs, you want to get the first one song or two song or some list of songs, you can do sub list as well, and you can sort it using a comparator class. So different options we have. Okay, I hope you get it. And there are, yeah, this we will try to understand with programs. So far, just give me a yes or no whether you are able to follow up, or you want me to reduce my pace a bit, or you are okay with my current pace. Some feedback give me in the message. Yeah, Raj Purohit, Akshat, Sairam, Aditya. Okay, I know it's a bit pacer. Maybe I'll keep it a bit slow. Okay. So I've written multiple examples, but we'll stick to this. So let me clear my console. Let me get the output, and then so list, and then list ops demo. Okay. So let's try to understand operations in next 2-3 minutes, and then we'll implement that in the Spotify. Okay, so this is the complete output. Now let's try to understand what is the program. So everything that we will do here is we'll see what all operations and how the output is getting impacted. That's all we will do. Okay, we'll not go to slide for list now. We will stick to this one program, and then we'll jump to Spotify, and we'll wrap up list. I hope that is a bit, I'm trying to make it interesting and knowledgeable. Okay, so first you see we are taking array list for an example, and we kept it empty. So what we are doing first, we are adding red, we are adding green. Okay, and then after red and green, we said you update with the blue. What index? So you have red and green, right? So let's say red is in the first, green is in the first, and then you are saying this is 0th index, this is first index. Let me increase the font a bit more. I hope you are able to see now more clearly. Or I think, yeah, let me do this. Yeah, I think this is more visible to you. Um, and one last. Okay, let me increase a bit. Yep. I think now it should be fine. So what I'm doing is red is our zeroth, like because the index start from zero, and then we have green called one. So zeroth index, first index. You're done with these two operations. Then you are saying, hey, there is a zeroth index, right? You replace the color with the blue. So it means the red becomes blue. You're okay, right? Now let's print it and see what is the output. So if you see, after adding, my current is blue, red, green. So you see, the red is gone. Okay, and on the zeroth index I have blue. I think we are clear, right? What is the difference between this add and this add? Here I'm specifically saying where you put it. Here where it will keep at the end. So previously it was red, and after that I said green, so it added green. So we see, right? Now it's done. Now let's see few more operations. Now we are saying set. So if I say add, then it will go and insert it. But when I'm set, it is going to update it. So what is my current value? Blue, red, green. So in this blue, red, green, what is the first index? The first index is red. So red will be replaced with yellow. Okay. Now if you see, I'm printing it again, and after setting the blue, yellow, green, because the red has gone now. Red has become yellow now. Okay, similarly, let's say remove. So if you are saying remove blue, okay, where is blue? Here, so that is gone. So here what we did, we said remove by value. Similarly, we saw remove by index. So if you see, after removing blue, yellow and green, okay, and now we are saying remove the element that is at zeroth place. What is at zeroth? Yellow. Okay, so yellow is gone, and now we have green only. I hope you are clear. Now here, I think if you were in the classroom, you would ask me one question. What if I'm storing all the integers, okay, in my list, and I want to remove the number called 1? But if I say remove 1, will it consider it as index or will it consider as by value? Okay, so the answer is it will consider it as index. But if you want to remove a specific value, you can use this. But how will you write in case of integer? So this is how you will write. Instead of saying you remove the element called 1, you will say integer dot value of 1. Okay, then you are saying that you are talking about the value, not the index. Okay. Yeah. Okay, let's go to few more. So now we are using same array list, and we want to add this list. Okay, and duplicates are allowed. So list of means it's already a list that we are getting, and we are going to add all those list items in our list. Okay, so if you see, after we do that, we are checking few things. Does it contains red? We will get true. Does it contains, and if it contains, give me the index of it. So where is the index? If you see here, it's at red. Okay, because we added here, it's at one position because already one element was there, which is green. Okay, so after this, what my element became? Green, red, cyan, and red again. Duplicates all around. So if you say give me the index of red, first it will give the first occurrence, that is 1. Okay, uh, I won't go through all the options, all the operations, but I will go through one critical operation, which is sublist. Okay, so what is sublist? Now you have so many items, right? Now when you say give me a sublist, you are saying give me index items from 1 till 3, but it does not include 3. Means index at 1, index at 2 you will get. So two songs from the playlist you are getting sublist. Okay, now is this a different copy? No. If you do any operations on the sublist, it will reflect to the parent. If you do any operations on the parent, it will reflect in the sublist. It means we are using the same list, but we are focused on only small piece of it. Okay, so yeah, I think after this session you go through all this operations and try to run it, And let's see, okay, how it goes. And if you have any questions, then you can ask again. How you can ask, okay, we'll see that. But yeah, so there are few more operations and different fail fast. We have iterations. Okay, let's spend 1 more minute on iteration. Just tell me yes or no, have you ever used iterators, or you have used for loops? Just say yes, no, for loop, iterator, something in the message. Yes, okay. Have you used for loop or iterator? Just say for loop or iterators in the message. For loop, okay. For loop, okay. So no one has used iterators, okay. All right. So in the list, right, we can use for loop, iterators both. Okay. But let's see what is bad in the for loop. So what we are doing here is, let's see, where is for loop? Yeah. So I have a list called colors. In that I have multiple items, right? How do I write for loop? This is advanced for loop where you say, let's iterate one string at a time from the list called colors. So first time S would be AA, second time S would be XB, third time S would be like that. We will do iteration and we can do any operations. Okay. Now in this for loop, what you are doing is you are accessing the element. Okay. And then you are saying remove it. Now as soon as you are inside for loop and you do any such updates, okay, your operation will crash, your program will crash. Why? Because as soon as you start this kind of for loop, it creates a value in its mind saying I have 4 elements, so I have to iterate 4 times. Okay, I think you are clear because you have 4 items, you have to iterate 4 times. But as soon as you remove or modify anything inside it, that counter which maintains the number of items, we have multiple, the mod count and the actual count. I will not go much deep, but assume there is some counter which will not get updated, and here we will get CME exception, the concurrent modification exception, because there is two operations happening. One, that counter update, and one, the operations that you are trying to do. So how, what is suggested, what is fast, what is good in case of these items, and what is that way in which we can modify the operations, like delete the song from my playlist, or move it to a different playlist while the song is playing, or while I am moving across the playlist. You can use iterator. Okay, so what is the difference between for loop and iterator? It is also for iteration, for loop is also for iteration, but in case of iterator, the counters that we were talking about, once again, one second, yeah, the counters that we were talking about, right, that will also get updated dynamically. Okay, so if you did not understood, the takeaway for you is, if you want to modify anything while doing the iteration, you should go with the iterators and not the for loop. Okay, and there is a way to make use of for loop also for this, but we will take some time for that. As of now, if you want to modify, yeah, this is also for loop, this is also for loop, but this is using iterators. Okay, not the regular the I j k, that kind of thing, and neither the advanced for loop. We should make use of iterators. All right, so we will spend a final Spotify demo, and then we will move to our last topic of the day, which is map. So let's see. All right. So if you see, I'll minimize all the methods. So in the playlist, what all options we have? We have add, we have swap, we have remove explicit. So there is some value we will call remove the explicit, and we have to filter it and remove it. Okay. Sort by rating. Up next means return a view or give me the next 10 songs. Okay. So these all operations of the playlist or Spotify, we will see how we can implement using a list. Okay, then I'll give you two more real use cases which you can do after the session is done. Okay, and let's see this. So how do we add? We will, if you see at this, at the beginning we have something called track. So in this we will do all the operations. So to add anything, we will simply use an operation called add. Okay, to swap anything, we'll simply use an operation called swap, which is provided by collections. So if I take you to the PPT once again, you see all the operations that we have in collections, okay, are available for list, are available for queue, are available for the set. Okay, because you see there is an inheritance between them. So that's why I can apply collections dot swap on my list. Okay, so here I'm giving it two operation, which two songs it needs to swap. For example, I need to listen to this first, then that of other. And if I want to remove anything explicit, this is called filter. So I'll pass my complete track, okay, this track, and it will go inside it. And what it will remove? It will remove wherever the explicit is true. So what is explicit here? Explicit is nothing but it's a boolean value. Okay, so I'm passing all the, yeah, I'm passing all my track songs. I'm saying wherever explicit is true, you remove it. So this is, I think, I don't know which Java version you are using, but this is how we are doing in the recent Java versions. Okay, so we are saying filter this, and wherever the output is true, it will remove. Okay, try to run it after the session and then sort by rating. So we are making use, don't write a generic way. I don't know if you have seen this kind of code before. I think nowadays people are using, not people, students are writing in this way. So we will say first comparator, and then we will tell it you compare two songs by what parameter. So here we are saying in this track there is a attribute called rating. You compare it using this, and in what order you keep it, and then you compare. If there is two songs with the same rating, then you do what? So then you compare it with the title. Okay, so this is how we are making use of the sort by rating in our list. Okay, then for up next we will make use of the concept called sublist. Okay, so let me run this, and then I think we should be good with all the operations. uh, you can mention again while I'm running this whether I'm going at a very high pace or low pace. It would be more interesting if you're asking anything or a bit interactive, but you can mention in the messages if any questions. Okay. Okay, let me run this, and then I will read that question by Aditya. Okay. So Java, and then this is list, and then Spotify. Oh, sorry. Yep. Can't find. Let's see. Java list. Spotify demo. What happened? Okay, main it is. What happened? Let me go to the readme, and then yep, this is what I have to do. So I'll go inside list. Okay, so you see all these operations are happening. Initial playlist was all these songs. It is separated by comma, and whether what is its rating and whether it's explicit or not. After swapping, what is the status? All that we can see. So all this operation that we discussed, you we have written. And what you can do is you can, just like you do any clicks on your mobile, you can write the operations here that you want to swap, you want to sort it by different parameters, and then you see how the functions are working. Okay, I think that's all for the list. Okay, okay. Now, while discussing about iterators, sir, what about the while loop? Would it produce the same issue like? Yes. Okay, so while loop, for loop, all these are using a mod count, a count of how much I should iterate or what is that condition. Okay, so it will be there with all. But I told you one more thing. Then shouldn't I use the existing for loops like without the iterator? You can, but how? Let's say you want to remove it. Okay, so you should not use remove function, you should use a different operations. Okay, so for the basic loops that we have to update, so if I phrase it a bit differently, I told you don't use the basic for loops, use the iterators. The reason was because of the counters not getting updated. But if you want to use the basic for loops, you need to use the operations inside, which also does the counter updates for you. Just like iterators, automatically it is doing. But if you are using basic loops, you have to do yourself. So it applicable for while loop, do while, um, not switch. Yeah, that is not a loop, and for loop. Okay. All right. So I hope this is clear, and then let's move on to our last topic. I know you'll be exhausted and it's a lunchtime, so bear with me for half an hour more, and then we will see. Okay, before I go here, let's take a minute. And yeah, let me take this use cases. I kept sublist, we did fail first iterator, performance, yeah, this, and then Spotify playlist we did. Okay, the same thing that we discussed previously, the Tesla sensor, and the use case that you can implement, Netflix, where you have continue watching, how you can, provide the implementation via sublist and iterators. Try to write it. Okay, so only if you try to implement it, you will be able to understand the concept. Just like you want to learn a React, Angular, or any such frameworks, what do? You try to clone, or you try to imitate uh, Google, you try to imitate, uh, let's say Facebook, you try to imitate big platforms, right? That's when you know all the functions and libraries available by a framework, and then you develop your own project. Okay, yeah. So here, um, yeah, I think take your time, and should I? Yeah, yeah. One question we will see, and then we'll move on to next. So, random access time in array list. What is it? Is it constant? Is it linear? Is it logarithmic or quadratic? You remember the options I said, whether it is continuous or whether it is at different places, how it is. So in array list, random access time, that is fetch time. Which one is it? Is it constant, linear, logarithmic, or quadratic? Just let me know in the message. Okay. So only Ram and Aditya, only two members are very much active. Others, why you are not active? Okay, Akshat, linear. Just mention wrong. That's fine. We are not giving example. I mean, we are not giving exam, right? Yeah, 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 yeah. Okay, so it is linear, right? Now it is, sorry, it is constant because it is always O of one. Okay, you can say there are n elements, so it might increase linearly as the element increase. No, it will be always O of one because you are talking about time complexity. Okay, so if you have 10 items and you are, so it will take 10 seconds. If you have 19 items, it will take 19 seconds. That's not how you calculate time complexity, right? If it's the n square, or it is n cube, or it is log of n, that's how you calculate time complexity. So here it is not O of n, it is O of 1. You are saying, get me this item, so it already focusing on that arrow and it knows where to go, so it's O of 1. All right, so the remaining questions you can see, and in the next slide you can see the answers as well. Okay, now before we start this map, I took one poll in the beginning of this session where you all mentioned that you all have different interest in different domain. Okay, so when I am learning something, what I do is I don't just start implementing it. I try to know the maths behind it. I try to know the end-to-end concept behind it. So whenever I get into an issue, I know how to fix it. Okay, so if you want to know from the scratch, from the core, with the concepts, okay, it will take you a bit of time, but after you are saying you are good, you will be able to easily resolve any issues. But if you directly start with the implementation without any knowledge, then when you get any issues, you will take time. Okay, so either start quick and stuck, or stuck or start quick. Okay, why I'm telling you this is that's how I learn, and I have resources for it. So I usually teach on a YouTube channel called Dpoint. And what topics do I keep? Let me share. uh, this one. Okay, let me go here. So I see people are interested in crypto, people are interested in data science, people are interested in cybersecurity. So I hope people who are interested in their domains are doing practical labs already and trying to contribute open source contribution. And I hope you are doing all that and you're keeping on your GitHub. Okay, because if your GitHub is your portfolio, that's what you are showcasing. So if you're not, start doing it today. Okay, so even when I'm taking the session, I keep my notes on the GitHub so that it is easy for you to access, and I can also showcase to others that okay, this is what the content is. Okay, and even if your system crashes, it is there. So if you're not using GitHub, start using it. Okay, so this is the channel, and if you can see recently or currently, we are working with various students, and in offices with LLMs, agentic AI, Gen AI. So this is the latest playlist which is going on, and every week one video I'm posting. But if you are interested in crypto, you have a crypto playlist of 9 videos, including the gas, blockchain, Bitcoin, how this works behind the scenes. You have automations, you have cybersecurity, and you have Python, machine learning, you have finance, everything you have. And you have Python knowledge, you have Spring Boot knowledge, anything that you want, you can maybe refer this. Not uh, the thing is, I do explain here, including the maths. So if anyone is interested, they can. I'm keeping it in the chat. Uh, okay. So with that, okay, this chat I kept. And one more thing I want to share is this link. Okay. So after the session, if you want to, uh, after the session, yeah, if you want to, yeah, look at the programs that we ran, you can find it here. I will share this deck as well, so this link also I will keep in the chat. Okay, so I shared you the GitHub link, I shared you the YouTube link, and yeah, so I hope we took a 5 minutes break now, because I didn't explain you the concept. So now we'll start on the maps. All right. So if you're working on Python, you might have worked with the dictionary. Okay. So it's a collection which provides us with the key value kind of storage. Okay. So it stores key value pairs with unique keys. So when you are getting an admission, each unique key will be assigned to your name, because it is possible that the names can be duplicate. For example, Bharat. I can have multiple students with name Bharat, but I will give a unique key, a unique roll number to Bharat, so I can recognize him, right? So I'm storing Bharat's information as a key value. What will be my key? His roll number. What will be my value? Maybe a class which contains all his information, or it could be a simply a string with the name Bharat. Okay, I hope you are getting it. Okay, so here if you see, I am using a map whose key is of type string, value is of type string, and I'm storing what? Phone numbers. So both I'm storing it in a string format. Okay, so if you see in map also, we have different types of map: sorted map, hash map, tree map, linked hash map. Now, without understanding what it is, but just by name, if you can say hash map, it means it makes use of hash to calculate the keys and store it. Tree map, maybe it's something to do with the tree, some kind of sorting related to binary or anything. And then linked hash map, okay, it has linked means it maintains the arrow, that is, it maintains the order or what it does, and then it makes use of the hash to calculate. So is it fast in terms of writing? So that's how you understand, because you know the terms now. Okay, you know what is hash, you know what is map, so what could be hash map? Okay, that's how you try to answer, and then we'll go to the next slide. Okay, so what we are going to do at the end of the session is, we are going to implement the Uber Ola use case by maps. Okay, so overall what happens in the Uber? There are drivers and there is a map. Okay, map is divided into cells, let's say this coordinates. Okay, and when you are operating, you want to know what are all the drivers are available in your distance. So maybe first it will search in your nearest 2 kilometer, then it will search in nearest 5 kilometer. That's how it goes on, right? And then once the driver accepts the ride, okay, where he is currently, you get updates. Okay, whether he's able to take one more ride, app gets update. So all this we will try to implement after 5 minutes, using the knowledge that we will consume in next 5 minutes in map. Okay, so here we go. So first we'll see hash map. So when you have fast access, you want to fetch something fastly, and you have a very frequent reads, you want to do searches very frequently. So those kind of lookups, and if that is the purpose of your, then you go for a hash map. Okay, so here you can see the get, okay, the fetching time or even the insert, both of them are approximately O of 1. Okay, what is linked hash map? When you need to maintain the order or you are doing frequent inserts, you go for the linked hash map. And I hope you are aware of what is cache. Okay, so one such implementation of cache is least recently used cache. Okay, so we will see how to implement LRU also. I have done the implementation, but based on the time we will see whether we'll go through it or not. But I think we have 20 more minutes. So let's see. We will try to understand LRU. And then we have tree map when you need sorted keys. So just now we discussed trees means something to do with the sort. Okay. So it is when you want in some sort of sort, in some kind of sorting order, then you go for a tree map. Similarly, we have different maps. Okay. Now, these kind of thing nulls. Okay. So you don't see the content. Okay. You try to understand what it does and then you try to answer. For example, tree map. So it need to sort. So there will be a tree in that you will have a nodes because you might have come across binary trees, binary search trees, or multiple kinds of trees, right? So in that value is stored based on which you see whether left, right, where. But if it is a null, you cannot do that. It means the tree hash map or tree map doesn't support nulls. Okay, so that's how you do the reasoning and then you come and see this slide. So by default, when we say map, when we say list, it is array list. By default, when we say map, it is hash map. Okay, so yeah, these are the few of the use cases when to use which one. I hope you're able to understand, and let's move on to next one. So what are the core APIs we have? We have, just like in list we had add, we have put here. Okay, and here we have put if absent. It means if 101 is not there, then you keep this item, but if it is there, you don't. So there are few operations. Let's try to understand this programmatically. Okay, so yeah, these, okay, let's see the core APIs programmatically. I hope you all are with me. I have your attention. Let's go with the map. So we'll take 5 minutes on understanding the core APIs, then we'll take 5 minutes on implementing the Uber, and then we are done with the day. Then we will disperse. Okay, so I hope you are with me, and let's try to understand the core operations of map. There are many, so we will go through few, and after the session you can go through all. Okay, so let's go to the map and let's try to run Java map demo. All right, so this is the output. Okay, now let's see what is the operations we are doing. And I, because I think you are at lunch break, let me increase the font a bit more, and I need your attention for 10 more minutes maximum. Okay, so let's see. So what we are doing here is, give me 1 second. All right. So we are starting with our main, where we are saying that I want to create a map which is of type hash map, and in that I will store string and string. Okay, and I'm calling it as phone. Now in phone, I kept one phone this with key as Alice and value as the phone number. Similarly, I'm adding one more record. Just like in dictionary, you open a dictionary, you have one record with the word and its meaning. Similarly, key and value. Similarly, here, the name and its phone number. Okay, so when we print the complete phone dictionary after adding these two items, this is how it looks. So this dictionary contains an open braces, close braces, and comma separated items. So before the equal to its key, after the equal to its value, and this whole thing is one record separated by comma, and then you have one more record. Okay, so I hope this is clear. And now let's see how do we access it. So when we say give me the record whose key is Alice from the phone dictionary, it will give me. Okay, you can see it is giving its value. Next I'm checking, does my dictionary contains this key? It says true or false, because if you see I never kept Eve before, that's why it's giving me false. Similarly, I can remove and do other things. Okay, so we saw how to add, how to remove, how to check if an element is present or not. Okay, now let's go to one more topic, which is how do we iterate over all the views key sets. So if you have a dictionary, you have multiple keys, you have multiple values, you have multiple records, right? So if you see here, first we'll start with the entry set. When I say give me all entry set, okay, if I say give me all key set, it will print Bob and all. So let's see, it is printed here somewhere. Yeah, keys. You can see all the keys are printed. So where are the keys? You can see Alice, Bob, Carol were the keys because Bob is removed. So we have only Alice and Carol. Okay. Similarly, if I say give me all the word values, it will give me the values. But if I want to iterate, I will say give me the entry set. So in the first entry set, I will have first record, okay, which is stored in E. So in that I can get a key, I can get a value. It means I can access all the keys, I can access all the values, or I can access records one at a time using a for loop. Okay, so that's how we do iterations in the dictionary. And then we have few more methods like add the element if it is absent, get me the element, or else give me the default element. For example, in my dictionary I don't have a key with the 999, but I'm saying get me this key whose key is 999, but if it is not there, you give me unknown. So that's how I'm handling any kind of exception that I might get if the value is not present. I hope you are understanding. So similarly, we have compute if absent. So I think you are able to understand. If not, once again, run it after the session. Okay. So let's say here we have something called available, and this something related to the Uber that we are going to implement next. So we have something called available, and okay, this I will explain you in the Uber concept, not as of now. But what I can tell you here is, yeah. Compute if absent means it will compute if it is not available. For example, when I want to do a summation, let me see here. Yeah. So I have a string array. Okay. In that, I want to store the frequency of each word. For example, the word two came how many times? Two times. Similarly, the word be came two times. So I want to maintain a frequency counter. What I'm doing here is I am using a for loop and I'm iterating and getting each word at a time, and I'm saying merge. So I'll get the word and then I'll say you increment my current counter by one. So that's how I'm merging and counting the frequency of each word. Okay, how is that relevant to me in the map? So here we are just seeing how we can use merge operations on the dictionary, how we can use the iterators operations and other options in the dictionary. Okay, yeah, I think if we spend more time on it, you can actually go through this program and try to understand, because we have only 15 minutes left. Okay, so see, I've implemented LRU cache. Let me give you an example of what is LRU cache in one example. So let's say there is an LRU cache and I'm saying maximum you can store three elements. Okay, so I stored first element, I stored second element, I stored third element, and I'm done, right? And what is this LRU cache made up of? It Here I have defined LRU cache that whenever you are crossing your capacity of 0.7f, which is your factor, you tell me already to increase the size or not, or you want to keep a maximum capacity of 3 or 16. Okay, so maybe I'll not make it complex, let me make it simple. So I said the maximum capacity of u is 3 and I stored three elements. Now I'm doing one operations called get. It means the get is on my stack first, and again I'm storing one more element. So which element should be removed? You sorry, when you have three elements and you want to store one more element, by default what your knowledge says, you should remove the oldest element, right? So here what was the oldest element? 1. So 1 should be removed. But what is cache means? Cache means something you store which is frequently or recently used, right? So recently used could be any operation. It could be fetch operation, it could be keep operation, or any operation. So if you see, this was the latest operations, and then one was also recently accessed. Means the operation which was done on the oldest element was 2. So the 2 will be removed and we are left with these three elements, 3, 1, 4. I think I should not bombard you with more thing at once, but I hope whoever out of 38 members, at least few members understood what is LRU cache. But yeah, here what method we used? Get and put method of dictionary, and we implemented LRU cache. Okay, similarly you can see how the tree map helps, how the how the keys are compared in the hash map or tree map or in the maps. Okay, and other options. Okay, you can simply say java space your program, and that's how you run it. Okay, and one last program we will see, which is the Uber. Yep, yeah, immutability. This last program that we will see, and then we'll wrap it. Okay. After that, we will see how much you understood and what other examples that you can implement on your own. So let's go to this Uber example, and I will let me run it. That's fine. So if you see here, what I'm doing is I'm creating a record type, or if you not used record, say it as a class. But if you have used, use records. Okay. So what is there in uh, okay, one second, this is an interface, yeah, driver. Okay, I kept empty here. Dispatcher, yes. Okay, let's say you have few operations like appear. So what appears means you are searching in a cell in a Google map. Let's say you are searching for Chennai and you are saying in Chennai, maybe I'm taking a big example, you take a small example and you say in this area what all cabs are appear is there, right? So you will see if there is any available drivers. Okay, you will go through all the drivers and you will see in that available drivers which driver is in this specific zone. Okay, and that's how you do compute if absent, and you say if that list is in this much distance. Okay, if the driver is in my list, you add that in my list. Okay, so here you are basically saying a driver appears in a cell, so that's how you're calling this function. Okay, as soon as you are searching for a let's say for a coordinate, a square, and as soon as the driver comes in here, the app will call this function and say in this cell, if you already have drivers, you add one more driver because this driver is now in your zone. Okay, and when the driver is moving from one cell to another cell, you will update the driver's location from previous xy coordinates to a no xy coordinate. So how you are doing it? You are removing it from one cell, you are adding it in the other list. Okay, and if it is so what you will do, two operations, right? You will remove the driver from his previous cell and you will add the driver to the new cell. Okay, again you can make use of same dictionary operations. Okay, and how we are doing it? We are considering drivers and cells as two entities, and we are doing all the operations. Okay, and when you want to accept a ride, what you will do? You are iterating over the available drivers, and in that list of available drivers you are removing the driver who accepted the ride, right? So if you see, these are the list of available drivers. In that list you are removing your current driver whose id or whose key you have it. Okay, so that's what you are doing. Okay, and nearby, so you will go through all the drivers and their coordinates and you will check if their coordinate is matching your coordinates, and if it is inside 1 kilometer or 2 kilometers, you can see radius is something we are doing. So how you'll compare the distance? You know Euclidean distance and other distance, right? So if the difference between the x coordinate is 1 or y coordinate is 1, you'll compute the distance, and that's all. So that's what we are implementing here using our drivers, and we are computing the nearby drivers. So you go through it once, you try to implement. The whole purpose of me showing you this program is that uh, just because you are understanding map, this much complicated use case can be implemented using the basic collections that you are going through, because you know what is map. But if you see such kind of example, you'll understand, oh, this is how it actually happens. Next time you open Uber, this should come to your mind. Next time you open Swiggy or anything, you try to understand, oh, I'm clicking this operation, so what kind of collections is being used, what kind of operations is going behind the scene. So with that mindset, if you see, then collections is very easy, and I think competitive coding is also easy. Okay, so the same thing we have created here. We have created different cells, we have created different drivers, we have added to our dictionaries, and then we are, doing different operations. For example, accept my ride, move the driver. Okay, and then show me the current state of my driver and the other driver. So try running it and see what operations you see in the code versus what output you see below. So yeah, and if you are able to understand that code, try to implement this continue watching progress. You see your internet goes away. Okay, and once you get your internet again, you again are able to see from where you left it, so how it is stored. Okay, and you have multiple playlists. When you share your playlist with other users, all of you can listen to the same playlist, different songs, right? So how the collaboration is working. So here just a hint was given that compute is absent is what you are using. Similarly, you try to implement different what do you say, you try to implement different use cases. And one suggestion which I saw in college usually students are not doing is basically keeping it on the GitHub. So you try to maintain your portfolio. It should, like, you should maintain portfolio like this, what you are doing, what your current languages are. Okay, and you should, just like your other streak like Snapchat and other, we should be able to see your current streak, and this shows how much commits you did, how active you are on GitHub. So it's like a resume for you. So you should be able to make it completely green. For example, today I did commit, so it is a light green. If I do more commits, it becomes dark green. Okay. Now, why I'm showing you this again is, one thing is you start using it, and second thing is this also makes use of collection behind the scene. Okay. So when you are using it, you try to understand, okay, these are the list of collections that I have. What collection could have been used here? Okay. Even for visualization, what kind of collections are being used here? Okay, if I go to inspect element, okay, let's say there are multiple API calls are happening, right? Let me refresh this here, network. Okay, there are multiple API calls are happening, right? And if you see the responses of anything, okay, I'm just opening. Okay, yeah, you. Okay, this is an HTML response. Let me go to some other data response. Okay, okay, maybe this one, array or linked list. So I'm not getting a proper API here, or I need to search. So for example, when you search this, you are getting a repository. So the repository is coming as a JSON. Is it list? Is it um, is it dictionary, or how it is coming? How are we storing? How are these are happening? So you should understand that concept, and you try to understand that whenever you are using any other website, any other platform, and that's how you can improve. That's the only way of learning, is what I'm suggesting. And I hope I was able to make the concepts clear. I wanted to keep it more real, as much as realistic as possible. So I tried to bring you that use cases. So what I will do is I will add the deck also uh, to this GitHub, and I will ask Vinita ma'am to share with you all, so you can go through that deck and use case, and you can try to implement that. Okay, yeah, I think that's all from my end. You have any questions, you can ask in the comments, or Vinita ma'am, I think I'm good. Okay, I think people want to go for lunch quickly, and yeah, I think I took correct amount of time. So yep, yeah, 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 sure, yeah, yeah, yeah. Thanks, ma'am. Sure, 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 sure. Yeah, thanks, ma'am. Thank you, all the students. I hope you implement that in real time. Thank you all.